Hello, my name is Clint Halstead, and this is an internet course called Introduction to Microprocessors. This is a PIC16 LCD project using 4-bit wide data to send to the LCD New Haven display using Multisim and MPLabX. We use Multisim to simulate the project as an emulator, and then we also use MPLabX to do some emulation and some coding and downloading to the actual chip. Here is a photograph of the actual PICDEM lab that I'm using to implement this LCD project. You can see here that I've wired onto the prototyping area a PIC16F84A, and I wired to the PIC16 serial header. Basically I'm just saying welcome on the screen. I have a pot that controls the contrast of the LCD, and that's all there is really to it. Just wired straight up to one of the ports. I have four bits of data going to the PIC port. I have 3 bits of data for the control, and that's about it. And wired up to the PIC kit. This is just another view showing how I wired it. So the question is how did I get that working? And I'll show everyone how I did that. I use a combination of Multisim and MPLabX. So the Multisim thing is pretty cool. Actually, if you go to Multisim, I have version 11. And if you actually go to the blue folder and click Open Sample Design, then Multisim has lots of sample circuits that you can use, which is really neat. One of the ones they have in one of the folders they have is called MCU, which means Microcontroller Unit Sample Circuits. Under there they have 8050, which is the old Intel chips. Some people still use that, and then they got the PIC samples. That's pretty much all they have. And this LCD display sample is what I'm using, and then I modified it. So you can see here that the schematic is basically just a PIC16F84A. We have 4 bits for the bus going to the data on the New Haven character display, and then we have 3 bits. So 4 bits of data, RB 7 to 4, and then we have port A, RA0 to 2. We have the control lines, and then if you go over here, you can see that they've got this wired to a bus signal, and you can see 9 down to 11 is going to E, which is basically the clock. It's like an enable clock. RS, and then read-write. So that's pretty much it. Then you have the ground and VCC to power up the backlight, and then you have the actually brightness of the display, which is on the VC pin. And so I have that wired to a pot on my design, and I'll show you the difference between my design and this one in a minute with the EagleCAD. But for now, that's what it is. It's got a master reset. They have a switch wired up to the master reset. So the cool thing about Multisim is that you get to play around with the hardware and the software, which a lot of microprocessor classes are very heavy on the software but not very heavy on the hardware. Here, if you change the hardware, it's going to affect your design, so you have to make sure that both your hardware and your software are working. So let's just run this. Click the run button, and you can see that it basically just prints out welcome to ELN to 232. That's the name of the class that I'm teaching. So I put that in there. If you right click on this and say properties, and then go to code and then go to properties and double click on the .asm file, then it will bring up your assembly line code. And I modified this a little bit. What I did differently was I added this list command, config command, and the radix command. This is what you need to add to actually implement it in MPLAB-X. This is the config register. It's an assembler directive. Config, low power oscillator, because I am using the low power oscillator. I forgot to show you that, but if you go back to these pictures, you can see here that it's hard to see, but there's a low power oscillator down here that I've actually wired directly to the chip. And it's right here, kind of hidden. You can see a little bit of it right here. That low power oscillator right there I have wired to this chip. So I'm using the low power oscillator, got the watchdog timer off, power, I forgot what this means, power up or something off, and code protect off. Also, I'm writing to the EEPROM data register, because basically what this does, this data, this welcome to ELN232 ASCII data is stored in the EEPROM area, which is a non-volatile area of data memory. So you don't have to store it in your program memory space. So if you look up these codes, DE is the command, is the assembler directive command to store it in the EEPROM. Then 57 is ASCII character for W. 65 is ASCII for E. 6C is ASCII for L. So it spells out welcome, and then two zeros on the end. So this one here actually particularly says welcome. This one in this code here, welcome to ELN232, I actually went to the EEPROM area and actually just typed that in. But in order to use it in MPLAB-X, you have to put whatever you're going to say right here. So this code actually doesn't say welcome to ELN232, it just says welcome. And you can see that when you look at my pictures, because all mine says is welcome. And I actually don't really know where those two / lines, I never did really figure out where those came from. I'll have to debug that later. But anyway, that's the changes I made. So all this here is what I added in order to get to work with MPLAB. Oh, another thing I changed actually was also change some code in order to, you can see here I'm swapping nibbles and things like that. I had to change the code in order to get to only use 4 data address lines, because by default the example in multisim uses 8, and I didn't want to use 8 on my microprocessor because I only have 8 bits for port B, and then I have like 5 bits for port A, and I didn't want to use up 8 of those. Actually, you have 8. Typically, the example one has 8 lines for data and then 3 more for control. So that's 11 lines. I didn't want to use that many. So right now I'm only using a total of 7 lines, 4 data and 3 control. Now I can use the other pins for some other functionality, that switches and things like that, potentiometers. So that's the design. I'll put the code up here really quick for you, and you can see it. Basically the way it does is it has an org statement, starts at 0, you have a start, you set up your registers, you have the main, you read the characters from the EEPROM, you see whether or not it's at the end of the character. If not, then you call write character, which is write character to the display. Then you increment your address index, your character index. You try to detect whether or not the character is a 0. If it is, you try to exit the loop. If not, then you do this again. You just continuously go through the EEPROM data and then write out the characters. When you do get a 0, it exits and then stops. And you can step through this code by just stepping into like that, and then you can, let's minimize this, so you can actually, it's kind of neat because you can actually step through the code and see that it's being written to. So step, step, step. So I'm just going to step through this code. Subtract literal. And you can view, if you want to, you can, view, toolbars, you can view some of your registers. I actually forgot where those were at. But there is a place where you can go and look at your memory view, so you can see your registers, your status register and things like that as you're stepping through the code and debugging it. So you can see that W got written to the screen. If I continue to step through, move the EEPROM data to W register, move WF to the character, call write character, we continue to step through it. So it's pretty cool. You can actually step through it and watch what's happening with the W registers and the status registers. Now we've got the E coming out of there, so you can see how that happened. And so you can go through each line of the code and view exactly what's happening with the code and how it actually works. So it's a good exercise to go through. And that's free. I mean, you can download Multisim off of National Instruments website, 30 days for free. If you want to purchase a copy of it, then you can go to Studica. And if you're a student, you can get a copy for $40 from Studica's website. This is a site that sells software for students, and you can type Multisim and Multisim $39.95. Or you can just go to www.ni.com and you can download Multisim for free for 30 days. Products, software, NI Multisim. So what is Multisim? And then you can just evaluate Multisim now. Try Multisim. Download the software. So there you go. That's Multisim. Now how do we make it actually work in real hardware? Well, good old MPLabX, which again comes free with the PIC software, can be downloaded off of Microchip's website. You can see here that I put the code inside of MPLabX. I created a new file using the PIC16F84. I placed it in here. I've got my include statement, config, my EEPROM data. So window, you can go here and say, first before you do that, you need to clean and build it by clicking this little hammer with the little brush thing. It says loading completed. I can go to Windows, pick memory views. I can go to EEPROM data memory. You can see that in my EEPROM data I have 5765 6C, which is exactly what I've gotten here in my program code. Otherwise you'd have to type this in manually, which I actually have problems. You can see over here it decodes it, tells you that it's welcome. And I could type whatever I wanted here. I could type, you know, welcome to ELN 232, or put my name there or whatever, and it would type it out on the screen. So now that I do that, then I've got everything in here. I've already written it. I've stepped through to make sure it works, and then I just click the download button and click OK. It says detected revision, program verify complete. So it's done. Now I just go over to my software or my board. So I just programmed it. Now I can disconnect the header, and you can see as soon as you turn on the switch it'll just say welcome. So now you're ready to start developing your own mini computer. You can add a keypad to this, and when you go up or down you can write characters to the screen. And that's actually what I did. I took it to the next level. I'm actually making a project that has an EagleCAD project that has a character display on it. So what I did was I designed the EagleCAD using the 16F84. I'm actually going to use the 16F88 because the 88 has an analog to digital converter on it. So what I'm going to do is actually I added some switches on here. I've got an up, a left, right, a down, and a select, so that I can actually, there's a select button, and I'm putting those into the RB inputs, and then I'm actually sending the data out for the character display on the port A, RA0123, and then I got the control lines going to RB5, 6, and 7. So I kind of changed around the lines a little bit. I got my programming header here, and I also got a potentiometer that's going to RA4. Now on the 84 you don't have analog to digital converter, but on the 88 you do. So this is pin to pin compatible. The 88 and 84 are pin to pin compatible. So that's the schematic design. I have a linear regulator down here. Now I'm going to show you the actual board design. This is my routed board design with the ground plane. But basically what I have is my display, my New Haven display. This display is going to go here in this header, and I have my in-circuit serial programming. My PIC16 is going to connect here. I've got a PIC chip. Again, this is going to be the 88, and I've got some headers. I have some headers here just like the PIC dim lab, so I can plug in and connect to those whatever pins I want. And I have a power header here. So I can actually make a shield. I designed this so that I could actually make a shield, and I could add a motor board, or I could add various things to this little board that I made for later on if I want to add functionality. I have my knobs here. These are push button, not knobs, push button switches. So I have an up, down, right, left, and select. So I can select things on my LCD display. I could tab through characters and add my name to the display or whatever you want to do. And then I have a knob so that I could use it to tune in a frequency or tune in a number or whatever I want it to do with that knob. I have a power supply connector with a linear regulator. I routed most of this by hand, manually, and I placed everything by hand. And it took me about 4 or 5 hours to do this board. And had a student help me work on it as well. Also put some drill holes in case I want to add some little feet on it. So anyway, I just wanted to show you this board, and I haven't really got it built yet. but I'll show it to you when I get it done. And that concludes my demonstration for using 3 different software packages, which would be MPLabX, Multisim, and also EagleCAD, to design an LCD PIC project. Thanks.